Greetings, everybody. Once again, this is Mr. Wakefield. Well, let's go ahead and take a look at section 2.4 right now. And we're going to be graphing lines in this section, okay? You may have seen this topic before, but again, let's review it. Maybe there's some things maybe you forgot or need to brush up on. Basically, lines come from linear equations. Linear functions also, they call it as well. Basically, linear... What makes an equation linear? An equation is linear where if you, in this section you won't normally see any brackets, but if you have a polynomial on each side of the equal sign and you only have x's and not x to the second power or x to the third power, but you just have x's, okay, then that's normally going to be a linear equation. What makes these ones different, though, you can see that these are polynomials on both sides. You got two terms here and one there. And notice that we have, again, x to the first and y to the first. There's no like x to the second or y to the second. So that makes it linear, all right? But the difference is that it has two variables now, at least in these first couple problems. I'll talk about the next two after that because they only have one. But... when you have a linear equation with two variables, what we oftentimes do with it, not the only thing, but what we oftentimes do with problems like that is we graph them as the directions say here. Okay, so we're going to learn how to do that once again. Usually what we do, and we might see the other method here as well, but usually what we do at this point in our math studying life is that we are now very well equipped to be able to use the slope in order to graph, and so that's what we're going to focus on here, this second method. First method is also something that's sometimes used, but we're going to focus on the second method here using the slope. And so that requires that we put it into this form right here if it's not already in that form already. Please remember that the y and the x are the variables. The m and the b, they look like variables, but I just put those letters there, okay, as an indicator that there should be some constants in those two spots right there. Like, for example, y equal to 3x plus 2 would be an example of what we're going to be doing here. It could also be a minus sign right there. For example, you could have like 4x minus 3. These are all examples of the mx plus b form, okay, that we need to get it into. You cannot figure out what the slope is, or the intercept as they call it here, until you've done that. Okay, so let's get into that form first, and then we'll talk about the slope and the y-intercept and all that stuff. So jumping down to problem number 1, the way to get into that form is to remember that when we do have a linear equation, okay, as we've seen before, where you have, again, assuming there's no parentheses, they've already been cleared out, like here. What you do is you focus on the terms that have the variable that you're trying to get by itself. I circled that in red. In this case, it was x that I was trying to get by itself. In this problem, it's y that I'm trying to get by itself. So I'm going to call that my red term there. And then even though this term has a variable in it, okay, that's not the one I want to get by itself. The 3x and the 12, neither one of those have the variable that I'm trying to get by itself. So what I do is I call both of those green, because when you have a variable that you're trying to get by itself, you get the terms that have that variable in it on one side of the equal sign, and then the terms that don't have it on the other, okay? And so we're going to do that same thing here, and the way you do that step, like we did before, is we add or subtract terms over from one side to the other in order to get the ones that have the variable in it on one side, the one that you're trying to get by itself, that is, and then the terms that don't have the variable in it that you're trying to get by itself on the other side, like this, okay? And yes, please put the negative 3x in front of the 12, because that's how mx plus b is written. The x term is written first. What we do in order to get y completely by itself, because again, you can't figure out the slope and the y-intercept without doing that, is by dividing out the negative 2. But we got to be careful here. Okay, when you have two terms here divided by a single term, we need to actually go through the division process. And we saw this back in the section where we were doing circles, where you divide each term individually. See how we had the the 4 terms here, and then you divide it by a single term. You split it up like this. Okay, we're going to do that same type of thing here in this current problem. You split it up. Each term one at a time gets divided by the bottom, and then you simplify each one. Same type of deal. And so negative divided by negative is positive. Okay. And then positive divided by negative is negative. So I'm going to put the minus behind that. And 12 divided by 2 is 6. So I'm just going to write the 6 there. You could write 12 divided by 2 and then simplify it after that. But it's just easier to write that. One other thing we need to do that's very important is when you figure out the slope, you have to separate the x variable right there from the rest of the fraction, okay, so that you can clearly see the entire thing that's being multiplied by the x. So if you have the x, in other words, inside of the top of the fraction, you got to split it behind the fraction like this, okay, and it's always okay to do that as long as the x is being multiplied by whatever else is inside the numerator there, which it is. X is being multiplied by 3, so you're allowed to pull it behind it like that. Okay, and so now I've done it. I've gotten it into the mx plus b form. Remember, it's okay to have the minus here. That just means that the b part will be negative. So what is the slope? They do ask us for that. I'm going to call that m because m does represent the slope. Okay, and the b represents the y-intercept. Okay, even though they don't ask for the y-intercept directly, I'm going to write that down too because it's going to help me graph it. So the slope is whatever is being multiplied by the x, assuming that the x is behind the number, okay, not inside the fraction. And then the b is negative 6. If that had been plus 6, then you would have said that b was positive 6. But because it's minus 6, the b is negative 6. Okay. Now that you know what the slope and the y-intercept are, okay, there's just two things that you have to do in order to graph the line. The first thing, and you got to do it in this order, the first thing you do is you go down to negative 6 on the y-axis, not the x-axis. You got to go on the y-axis because, let me zoom in there a little bit. You got to go on the y-axis because the b represents the y-intercept. It represents, in other words, where the graph is going to cross the y-axis. That's what a y-intercept is. It's where it crosses the y-axis. Okay. Now, a little reminder here, and let me write it off to the side here. Okay. When your slope is positive slope. Okay. How do you do that? Okay, when you have a positive slope and you're actually trying to use the slope in order to graph it, you're going to do rise over run, right? Rise over run. But you've probably heard that expression before, but what does it literally mean? It means that you rise and then run to the right. I wouldn't want you to run to the left, okay? There is a way to do the left sometimes, but it's a whole different thing. So let's keep things simple here. We're going to rise and run to the right. That's the most popular way to do a positive slope. Okay, negative slopes will be different. I'll explain that here coming up. Okay, but for the moment, going back to the problem, since the slope is a positive fraction right there, we are going to rise 3 and we're going to run to the right 2. Rise 3 and run to the right 2. So let's do that. I'm going to go straight up 3 from the y. You have to go from the y-intercept. That's why I graphed that first. You go from the y-intercept, 1, 2, 3, and then you count over 2 to the right like this. And that brings you to the next point right there. So you rise and run. That gives you a brand new point. And as you guys know, 2 points is all you need in order to connect a line. And so all we got to do now is just draw the line, make sure it's straight, of course, like any line should be. And then also make sure that it has arrows on both ends of it because it's not truly a line unless it has arrows on both ends. Okay. And so that's the first problem right there. Okay, let's try that again now with problem number 2. Okay. And so, excuse me, there we go. And so in this next problem here, you can see once again that in order to get it into y equal to mx plus b form, I need to get the y term by itself, like I would in any linear equation. That means that I need to move over the other two terms to the same side, but the opposite side's got to be the opposite side of where the red term is there that has the variable that you want to get by itself. And so we get what here? We get 3y is equal to, now what is 0 minus 4x? Well, just like 0 minus 2 would be negative 2, and 0 minus 4 would be negative 4, in the same way, 0 minus 4x is going to be negative 4x. The 0 is not going to be there anymore, okay? And so we did it. We got the y term by itself. We now divide out to get the y completely by itself. And yes, I know that you might be wondering, well, what happens here since that second term on the right-hand side is missing? Okay, we just have y equal to negative 4/3. And I know that's negative because it's negative divided by positive. So I put the negative in front when it's negative. All right. Like we talked about with the circles, you put the negative in front of its negative, you put a plus in front of its positive, and you have negative 4/3 x. Notice that the b part is not there. When the b part is not there, it just simply means that the b is 0. The b is 0 when the b part is not there. As you can see here in the problem here as well, m has got to be negative 4/3 because that is the number that's being multiplied by x. Again, with the x separated. See how I pulled the x behind the fraction so I could see the whole thing that's being multiplied by the b there. Or, I'm sorry, by the whole thing that's being multiplied by the x now. I can see that it's negative 4/3. Let me circle that there. There we go. And so now, once again, just like in the last problem, what you do is you, first of all, graph the b, okay? You graph the y-intercept first because you got to be able to, you got to have a starting point to do your slope, okay? And the y-intercept is that starting point. Now, this time you'll see here that we have a negative slope, don't we? Okay, since we have a negative slope, let me just go down. Let me just go back up here. Unlike positive slopes, our negative slopes are going to be what? They are going to be not rise and run to the right, but they are going to be drop and run to the right. Drop and run to the right. Like this. Okay. And so because we have a negative 4/3 right here, this is going to be what? This is going to be drop 4 and run to the right. Let me just write down the word right here. Okay, we already know we're running. Run to the right 3. Run to the right 3. There we go. Okay. And so let's do that. I'm going to drop 4, 1, 2, 3, 4, and then I'm going to run to the right 3, and it takes me to right there. Okay. And that is that second point. And as you guys know, when we have 2 points, we draw our straight line through that. Okay. And we know that these graphs are going to be lines because when you have a linear equation, like I said at the beginning, that has 2 variables in it, it's going to be a line. And so you can confidently say, hey, I know that it's a line. I have my 2 points already sitting on the graph, and so I can just draw a line through it. If it was something other than a line, that'd be a different story. You couldn't just draw a line when it's not supposed to be a line. But these are supposed to be. Okay, now we know why. So, what's different about problems 3 and 4, you guys? What is different about those guys? They have only one variable. Okay, this creates a special situation. Do not do mx plus b, you guys, when this happens. Okay, one of the variables is missing, so it'll be kind of weird to try to do that anyway. Okay, what we do is we follow these special directions. Okay, right here. Okay. It says when the y term does not appear and the x term does appear, it's always going to be a vertical line. Vertical line means that it goes straight up and down. Okay. Whereas when the x term is the one that's missing and the y term appears, y term does appear, the resulting graph is always horizontal. That means it goes straight flat across. Okay. Now, this first problem here can be kind of deceiving. You say, oh, hey, the y is missing. No, actually, it's not. Remember, f of x is the same thing as what? Same thing as y, right? Okay. And so this problem is actually the same thing as y equal to 3. Okay, so that's one of those tricky things where you see the x, but it's actually the x that's missing because f of x is the same thing as y. And when the x is missing, it's always a horizontal line, isn't it? As we saw right here. And so what we do is we just simply go to where y is equal to 3. Don't go on the x-axis because it's the y that's equal to 3, not the x. And then you just draw a horizontal line through that. Okay. Make sure it's not going up or down at all. It should go straight across. Okay. And that's all you got to do on that one. No mx plus b. Okay, we only do the mx plus b thing when you have two variables, you guys. So these two problems you don't. Now in this next problem here, the y is missing. Okay. And so we know it's going to be vertical due to that fact. Okay. Vertical when the y is missing. But what do I do? Do I do x equal to 3 on the x-axis? No, we don't, because that's not what x is equal to. It says that x plus 3 is equal to 0. We have to get the x by itself, just like when we did the one variable linear equations. Again, let me put that back up on the screen here. Just like when we did the one variable linear equations before. Okay, here they are. Let me pull these up. Okay, again, when we had the one variable linear equations, you need to get the variable by itself to know what it's equal to. Same thing here. Okay, you get the term that has the variable that you want to get by itself. You get that by itself by moving the other terms over to the other side. There we go. And we get x is equal to negative 3. You don't even need to divide out. The x is already by itself. Okay, so let's go ahead and zoom in on that and take a look at that. So that one is going to be, since x is equal to negative 3 and not 3, we go to negative 3 on the x-axis. Again, make sure it's on the x-axis because it's the x that's equal to negative 3. And then as we said, the vertical line is supposed to go what? It's supposed to go straight up and down. Mine is not the most straight line there, and I'm not expecting perfection. Just so long as your graph reasonably looks like a line, it doesn't need to be perfect. Okay, make sure it's not completely crooked. All right, make sure it's close to being a line, and I'm okay with that. But that's what it looks like. Okay, so that is how you graph lines when a variable is missing. By the way, how did we know that that we were supposed to realize that a variable was missing? Or why couldn't it have just been one of these problems where there was only one variable? Why is it that these problems had one variable when we solved the linear equations before in a previous discussion, but here there is a second variable that's invisible? Okay, why is it that there's this second invisible variable in these ones but not those other ones? I know that because next to the problem here it has both an x-axis and a y-axis. Okay, and if I give you one of these problems on the test, you will see an x-axis and a y-axis, and so that will remind you that even though you see only one variable in the equation, there actually is a second one that's invisible. And then once you realize that there's a second one that's invisible, you will know automatically that it's either horizontal or vertical if you remember how to do these problems, if you remember what we talked about. Okay, and then you can go from there as we talked about. Okay, so let's go ahead and flip the worksheet over here, and we'll take a look at a little bit more here from this section. And taking a look at here on the back side of the worksheet, we have, it says here, graph the line passing through the given point and having the given slope. This is similar to what we just did where, remember how on the previous part here, we always started out with the y-intercept and then we use the slope in order to get to the second point. We're going to do exactly the same thing now. It's just that instead of starting out at the y-intercept, we're going to start out at that one point right here that they gave us. All right, remember they're saying to graph it here, okay, because you're going to see some problems in the next section where the information they give you looks similar to this, but you're not going to be graphing it. So just make sure you're reading the directions, okay? But what we do when they ask us to graph and they give us a point and a slope, what you do in that case is you start out kind of like you did with the y-intercept. You start out with the point. Let me zoom in so you can see it better. You start out with the point that they gave you. All right, negative 2 comma 8 is right there. Okay. And the slope is 2/5. Okay. And so you build off of that point right there just like you did with the y-intercept earlier. And since this is positive slope, we're going to say rise 2 and go to the right 5. Rise 2, and we're going to go to the right 5. And so I'm going to do just that. I know it looks like I'm almost going to go off the page here, but we'll be okay here. It just barely hangs on. So I'm going to go up 2, and then 1, 2, 3, 4, 5, right there takes me to that second point. Okay? So a very similar process to the problems we just did. Now I've got my 2 points, and since they tell us that it's a line, you guys, you know that once you get your 2 points, you're on your way. You just have to graph it. So let me draw my straight line. Make sure it's got arrows on it. Make sure it's straight, of course. Okay, and that's all you got to do. Same thing in the next problem here. Okay. It says right here to start out at negative 2, negative 3. Let me put that right here. Negative 2, negative 3. And then since we're supposed to have a negative slope right here, we're going to what? We're going to drop 3 and go to the right 4. Drop 3 and go to the right 4. Okay, because it's a negative slope. Remember, negative is the one that you always drop and go to the right. Okay, so I'm going to drop down 3 and then go to the right 4. 3, 4, there it is right there. And then you're on your way. You just have to graph that point or graph that line now. And I got a little bit crooked there. Again, don't need to be perfect, but I want to try to be as good as I can here. Okay. There we go. And so that's what happens when you have a positive or a negative slope. Okay, so now when we move down to problem number 7 and number 8, and you'll notice that the slope in number 7 is 0, and the slope in number 8 is undefined. That is not the same thing. Remember, 0 is not a positive number, you guys. It is neither positive nor negative. So it's in a completely different category from a positive or negative slope. So let's go back to the front side of the worksheet when we were talking about positive and negative slopes. I just want to continue on with that discussion by talking about a zero slope. Okay, a zero slope, when you have a zero, and let's just kind of review fractions and how they relate to zeros here for just a moment. Okay, I'm going to pull out a piece of scratch paper here. You don't have to write any of this down here. But as your math teacher may have taught you way back when you first learned how to do division, they taught you what? They taught you that 6 divided by 2, how did you know that that was equal to 3, you guys? You knew it was equal to 3 because the bottom number times the answer has to equal the top, right? 2 times 3 is 6, and that's how you knew that 6 divided by 2 was 3. So let's talk about that now with zeros. Suppose I have a 0 divided by a non-zero number like 5. Okay? 5 times what, you guys, is 0? 5 times what is 0? Well, that would be 0, right? Okay, 5 times 0 is 0. So this is just a reminder, you guys, that when you have, let's write this down, when you have a 0 divided by a non-zero, if that is your slope, and like if you have 0 divided by 5, or if you have, say, 0 divided by 7, something like that, okay, that is going to be a horizontal slope, Okay, in other words, it's a horizontal line. All right, the slope, it's the slope for a horizontal line. Okay. But yeah, whenever you have 0 divided by a non-zero number right there, that is going to be equal to 0, and that's going to automatically, if it's a slope, if your fraction is a slope, then that's going to be a horizontal line. Okay, and the reason why it's horizontal is because if the top number is 0, remember the top number has to do with what, you guys? Let me zoom out here just a little bit so you can see everything. If the top number is 0, the top number has to do with rising and dropping, doesn't it? So if the top number is 0, that means that there is no rising and there's no dropping. There's only one line in the world, you guys, that does not rise and does not drop at all. Okay, and that's a horizontal line. So that's the reason why it makes sense that when the top number is 0, it's horizontal. Okay, now one other thing I want to show you here, back to the scratch paper. What if I have a 0 on the bottom? Question, 0 times what, you guys, is equal to 3? Yeah, it sounds like a trick question because you can't think of a number, right? Well, as it turns out, there is no number, and we call that an undefined answer when there is no number that could possibly make that happen. 0 times, you can't do 0 times anything to get 3, because 0 times anything, no matter what number you did try to do, would always be equal to 0, and it could never be equal to 3. And so if you end up with a slope, you guys, that has the non-zero number on top and the 0 number on the bottom, okay, that is a undefined slope, okay, but it's also a vertical slope. Let me move that down. Sorry about that. And a vertical slope as well. Okay, the reason why it's vertical is because, remember, the bottom number has to do with running to the right, doesn't it? The only line in the whole world that does not run at all because the number is 0 is a vertical line. Vertical lines are the only lines that are like that, where you don't run to the right at all. Every other line in the world runs to the right, okay, at least a little bit. And so that's the reason why, as I flip the worksheet back over here in a second, 0 slopes are horizontal, undefined slopes are vertical. And that's going to help us in the next section here as well, but it's good to know for now. So let's finish this thing off here. 0 slope automatically means, without hesitation, there's no other way it could be, it automatically means that it's horizontal. And then if we go back over to number 8 here, undefined slope automatically, 100% of the time, no doubt about it, means that it's going to be vertical. And the good news with that is that, unlike the other problems that we've graphed, you guys, when you know already that it's horizontal or vertical, okay, you only need 1 point. You don't need 2 points like you do in any other type of line. When it's horizontal or vertical, you only need 1 point because you already know what direction the line's going to go in from that 1 point. Okay, the whole purpose of graphing a second point, like in these two problems, for example, is that that second point points your line in the correct direction. Okay. Whereas since you already know the direction when you know that it's horizontal or vertical, there's no need for that second point. So all you got to do, in other words, is just graph the point that you're given, okay, and then draw a horizontal or vertical line through it. 3/2 comma 0. Now remember, 3/2 is, you can put this in your calculator if you want, 1.5. That means that it is 3 divided by 2 is equal to 1.5. As I mentioned in the circle section, 2.2, if you have a decimal or fraction that you have to graph, just put it in between the two numbers that you need to have it between. 1.5, as you guys know, is between 1 and 2, and so you just have to put it in between 1 and 2, and the y is equal to 0, and so that's why it's right on the x-axis there, as it always would be if y was equal to 0. Okay. And then since it is a horizontal line, we just simply draw a horizontal line through that. And sure enough, I know this looks kind of weird, but it's going to be right on top of the x-axis. Okay. So draw a horizontal line through that point, and that's what they're asking you to do there. 9/4, what is that? 9/4, if you put that in your calculator, that is 2.25. 2.25. So again, just make sure that it's between 2 and 3 as far as the x's are concerned. Okay, you don't have to make it perfect there. Just make sure it's between 2 and 3. And then make sure that the y is equal to 2. So that would be right there. Okay, 2.25 and then 2 for y. And then since it's got to be vertical, all you got to do now is just draw a vertical line through that. Okay. And that's it. Don't forget your arrows. Okay, so that concludes section 2.4. Okay, graphing lines. Again, as always, contact me if you have any questions. Have a good one.